Yesterday, we talked about the types of triangles. Today, we're going to concentrate on one type of triangle, only one, and that's the one that we call the right triangle. Now, if you'll remember, the right triangle has a 90-degree angle right here. And usually it's indicated with the little box in the corner. This is called a right triangle, and this is the only kind of triangle we're going to work with today. Because we're going to use it in all sorts of problems and lots of word problems, because you're going to see word problems with this right triangle. We're going to be using what we call Pythagorean Theorem. Theorem simply means a rule or something that's true. Okay, in this case, in mathematics, Pythagoras was a mathematician, so they named this after him. What you need to know to use Pythagorean theorem is the parts of a right triangle. Now, if you'll notice, I have a real silly way for people to remember the parts of this. The part that's most important in Pythagorean theorem is the hypotenuse. Now, the hypotenuse will be the longest side. The hypotenuse of a right triangle is always the longest side. Now, most of the time, you can just eyeball it and you can find out which is the longest side, right? But some of the triangles, they look so close that it's kind of hard to tell where the hypotenuse is. So if you want to remember, you know my silly stories. And so when I see this, I see a little man or a little boy sitting here, and he's fishing. He's fishing during the afternoon, just loving the sunshine. And while he's waiting for those fish to bite, he's looking out at the horizon. So he looks right at the hypotenuse all the time. So sit your little man on the 90-degree angle and look at the hypotenuse. That's always the case. Everybody okay with that? Okay, silly stories, but hypotenuse is always the longest side of the triangle. Now, Pythagorean theorem is actually a formula that you follow over and over and over again. It is a squared plus b squared equals c squared. Now, these A, B, C's are certain parts of a right triangle, okay? The A and the O, when I was telling you the parts here, this is a leg and this is a leg. They call these legs of the triangle, okay? Now, back to this. These represent the three sides of a triangle, a right triangle. The most important part that you need to put on your triangle first is the hypotenuse. And the C has to be the hypotenuse. The C has to be the hypotenuse, so that's the length of the hypotenuse. Now, whatever the A and B are, it doesn't matter if A is here and B is here, or A and B. Does not matter, but the C is extremely important. So I have an A here and the length here. And if we use this as a model, then this would be the way to find the sides, any side that happens to be missing here. Now you're going to find later on, I think it's maybe page 9 of your worksheet, you're going to find out that it talks about a Pythagorean triple.
So the C will always be the half that.
Always. Always. And we'll do some examples here so you can put all of this stuff together. But on page 9, they're going to talk about a Pythagorean triple. And what it means is if you put the measurements of each one of these sides in this formula right here, that it will create an equal equation. And we'll do some of those also. But they refer to it as the Pythagorean triple. Okay, it means that the sides, when they're put in this formula right here, create a true statement. Pythagorean triple. Tell me when you've got the notes that you need, because I need to erase, and we'll start an example already. Oh.
So it's called, why?
Pythagorean.
Yeah, triple, that's just the same thing.
Yes. I'll show you what it means. The theorem is the rule. And if you have a Pythagorean triple, that means the 3 numbers they give you fit in here and make an equal statement. Hi, Doris.
Hello, good morning.
We just started, Doris, and if you would like to, I have the notes on the board. So
Okay.
I might give you a minute to look over that or do a screenshot or use your phone to just take a picture of what we have written up here.
Okay, I got it.
You have it? Okay.
Yes.
Okay, we're going to move on then. And you should have received this packet in your email.
Yes, ma'am.
Okay, good. All right, let's see just how this works. And you're going to be using this over and over and over again. Pythagorean theorem says a squared plus b squared will always equal the length of c squared. So let's actually look. Go ahead and turn to page 2. Page 1 is just information. Page 2, number 1. And remember, if they give you a triangle that's not a right triangle, this theorem will not work. Only with right triangles. Only with right triangles. Now, oh, you're not even, we're going to be finding Pythagorean triples already. Okay, let's look at this. Number 1. What they're asking us here, they didn't put the right angle here. And what they're asking us is, here are the measurements of the triangle. You tell me if this is a right triangle or not. So, let's go ahead and put everything up here.
I don't feel like it would be
And 4 feet. I'll answer your question in a minute. I heard you, I just don't know if I understood your question.
So you gotta, so then you have, so basically the point of it is to get 90 degrees.
Basically, you have to fit your numbers into that equation. And if they come out to be equal or a true statement, then it is 90 degrees and you can put a 90 degrees there. If it doesn't come out equal, I'll show you how. Okay, here we go. So we said the most important part about this is that the C has to be the longest side. So right here, I'm just going to put my C so I'll remember where to find it. And then it doesn't matter about the others. They can be A and B or the other way around. So I'm going to take these numbers that are the lengths of the sides, plug them in to this equation and see if it's a true equation. If it's a true equation, then it is a right triangle. So we have, it's asking for A, and A is 4, and it says to square it, plus finding the length of B is right here, squared, equals whatever the length of C is, 5 squared. Now there are no X's in here. What we're trying to do is prove something. So we're simply going to do some math, and 4 squared is 16. 3 squared is 9, equals 5 squared is 25. And then we come down to our next set, add these together. 16 plus 9 is going to be 25, and that does equal 25. So this is a true statement with those lengths in the triangle. So you have proven that this is a right triangle. You'll see, and you can actually put that little square in there, and whatever they ask for, you can say, yes,
Wait,
it's, yes,
What if
it's,
it comes out, how is it not gonna be, how is it not gonna be true? Because
I
all
love,
the math would be correct, right?
I love that you're asking me. We'll try number 2 and see what it looks like. Yeah, number 2. Any questions on this one? Doris, you okay?
Yes, I'm okay.
All right. How about here, Mary? Yeah, okay. All right. So let's look at number 2 on this page. And again, they give you this. You know that your triangle can be faced any way. And number 2 says that this is 6 yards. This is 8 yards. And this is 5 yards. This is triangle E, F, G. These letters represent the point right here, point right here, point right here. This is triangle EFG. Okay, and then when we look at it, if we want to plug these distances right here, these lengths into the Pythagorean theorem, we have to first find the hypotenuse. What did we say the hypotenuse is? The longest side, and that's which one here? 8. So here's my C, and then the A's and B's don't matter. You can use either leg. So let's plug the numbers in. They want A squared. So we have 5 squared plus the length of B is 6 squared equals, and C, of course, is a hypotenuse, 8 squared. So when we do the math, we have 25 plus 36 equals 64. Now we need to add these together, and we get 61. Look at this, Christina. This is what you were asking about. When I do this math, and this math, then I add these together. Since they don't equal each other,
A and B have to equal
squares. Yes, A squared plus B squared has to equal C squared. You do your math. If it does not come out to equal to each other by plugging the lengths into the Pythagorean theorem, then it is not a right triangle. So in this case, you can't put that little square in there because it's not a right triangle. Okay? Does that answer your question about when it's not? Okay. And-
Not done?
And then the two words, the two problems at the bottom are simply word problems that are saying the same thing. So you will draw your own triangle. You will find the longest side, which is C. This is on the word problems at the bottom of page 2. Got it? Okay. Now let's go to page 3. What they've done is give you right triangles. Notice the little square in the corner says it is a right triangle. So let's look at number 1. What they're wanting us to do is find the question mark length, whatever that length happens to be. And then it's telling us there's a pretty good chance that it's going to be a decimal sometimes, and they want you to round those decimals to the nearest 10th. Christina, you want to come get a calculator? Because you're going to need it here. This is number 1 on page 3. Now this time, you will notice again, let me tell you, that when they put the box here, that means this is a right triangle. You don't have to guess. So they're either going to do this in the picture, or they will tell you those actual words in the instruction. So be sure and read your instructions when you get to the GED test. Now, in this particular one, this is triangle A, B, C. And the lengths that they give us is 12 yards, 15 yards, but they didn't tell us this one. And they want us to find out what the length of segment BC is. Knowing that it's a right triangle, I know that I can use this theorem to find the missing side. But first, I need to find out where are my ABCs, not these capitals, but these ABCs. The C is the longest side. It's the hypotenuse. So here's my C. Let's just make this the A and the other side the B. Again, the A's and B's can be interchanged. So what we're going to do is put this in our equation. And now is the reason that I showed you how to solve equations over and over and over and over again, because it always comes up. So here's A. What's the length of A? We don't know. So I have A squared plus B is 12 squared plus, and C is, equals 15 squared. Y'all okay? And this is just like solving for X. So we're going to put our line down through the equal sign and circle what we want to solve for. Don't circle the squared, just the A. Okay, the first thing I would do is go ahead and find out what 12 squared is and 15 squared. So now I have A squared plus 144 equals, check this for me, 225, is that right?
How is A on the bottom?
It doesn't matter. I could have made up and said this is B and this is A, doesn't matter. The C is the only one that has to be there. Then A and B are the other two legs, and it works no matter which one you use. 15 squared, right? 225? Okay. So now we want to solve for A. So I know I need to get rid of this 144 and subtract 144. So now I have a squared equals 181. 81. Thank you. Now, this is the part that some of you forget. Notice that if I was wanting to get rid of a plus, I use the opposite sign, okay? I minus, add and subtract are opposites. And later on, if I wanted to get rid of a multiply, I did the opposite, which was divide. And that's how I got rid of a multiply. But some of you may have forgotten, if I want to get rid of a squared, I have to do the opposite of a squared. Anybody remember? The opposite of squared is square root, okay? They wipe each other out. So since I want to get this squared gone, I need to square root this side, and if I do it to one side, it has to be done to the other side. So now, a square root and a squared are opposite of each other, so they actually cancel each other out and leave me with the A. Equals, and then you can either tell me what this is or find it on your calculator, but the square root of 81 is 9.
No, it's not multiplied.
Yes, because 9 times 9 is 81. So it's saying the length of side A, which is the one that we were trying to find, is 9 yards. Simply solving equations again.
Yeah, but doing the square root,
I didn't understand.
the square rooting thing is easy.
Mhm.
What would
Okay.
you call that? What would you call that? Whenever you said, in order to get rid of the square.
You take the square root. Okay. Okay, any questions on this? Believe it or not, you're going to use some form of this equation on all 9 pages. Okay, let's look at page. I'm just going to make sure I don't miss anything with you all. Now, the next pages, quite a few pages, are word problems. Probably on the GED test, they will probably give you the picture that goes with the words, which makes things so much easier. These are the easiest word problems you're going to ever do. Okay. Now, every once in a while, you're going to have to draw your own picture. But by the time you are through working these word problems, you're going to understand how these pictures need to be drawn. I look for the GED test to definitely have some Pythagorean theorem and probably word problems. All right. So make sure you pay attention to these and how they are drawn in case you have to draw your own. Let's skip down to, I see a lot of problems like number 4. Let's look at number 4, and I'm on page 4. It's about a tree and its shadow. A tree and its shadow. Okay. No, it's pictures like this.
It says these here, what does that mean?
That means this length from B to C. What is this mean? Okay. You're asking such good questions. It says
So we have put 81 or we put
9. Because 81 was A squared, and I'll just want the length A. Okay. Now, number 4, the words say a 15-foot tree. So whenever I begin to read a word problem, I just start sketching out something. and it says this tree is 15 feet, 15-foot tree. Cast a shadow, and casting a shadow means the shadow on the ground here. It casts a shadow. This is dark shadow. Okay, the shadow is 8 feet long. So 15-foot tree, the sun's about right here, and it's casting a shadow. Do y'all see? Okay, and then it says, what is the distance from the tip of the tree to the tip of its shadow? So we're talking from right here to here. Now, if you use your imagination a little bit, here, there's the height of the tree right here. And here's the shadow that they gave us. So, just so the drawing isn't so confusing, here's our right triangle, assuming that the tree is straight up. It's not in northern Oklahoma where the wind blows all the time. But this one was 15 feet, and they're asking you for this piece. But if you see that your picture creates a right triangle, it's a Pythagorean theorem, simple as it can be. You need to find out where your C is. Here's the little man looking at the hypotenuse. So there is our C. Our A and B can be interchanged. So we'll plug in our information. A squared is 15 squared. Don't forget your squares in here. Plus 8 squared, which is our B, is going to always equal C squared, the hypotenuse squared. And again, we're just going to use our math. So 15 squared is 225, plus 8 squared is 64, equals C squared. Since the two numbers are on the same side, all we have to do is add them together. So we have 289 equals C squared, but I don't want the squared. So I have to square root it. I'm going to square root there, but whatever I do to one side has to be done to the other side.
So wait, when you square root it, are you dividing it by a certain number?
No, I am removing the square. No,
Yeah.
you're not.
No, for number 3 on the last page, you divide it to 8 by 9, right? That's why 9, 8.
Yes, but you never know what you're dividing by.
Yeah, that's what I'm asking. How do you know what you're dividing by?
This, the number inside, is what determines it. And it's just the square root. It's not a particular divide by. It's different. Okay, so it's square root, and I can show you if you don't know how to find it on the calculator. I'll help you do that. Okay, so the square root and the squared actually cancel each other out, and I'm left with the value of C is whatever the square root of 289 is, and that would be 17. And so the length, it says the distance from the tip of the tree to the tip of the shadow is going to be 17 feet. That's what they want. So if you will look, I think there's like 4 pages of word problems. I did it because I think it's really important for you to see how they drew the pictures and what they're thinking when they ask for the words. So don't ignore the words when you're looking at this. Look and see how they put it into words. So if you have to draw your own picture, you'll know what they're talking about. Okay, so don't skip the words just because there's a picture. But we're going to be using Pythagorean theorem all the way through. Let's see if there's anything new or different. No, there's page 5, and it looks about the same. page 6 again, 7. See, those are all, and another one, 5 pages. You should get used to this. Okay. And then page 9 talks about our Pythagorean triples. Pythagorean triples. And we've already done this. The instructions just weren't the same. We said, if the sides of a triangle are given to us and we plug that in the Pythagorean theorem, if it comes out a true statement, it is a Pythagorean triple. All right. So let's go to one that might give you some problems just because it has something a little bit different in it. So let's look at number 2 on page 9. And what they want you to do is decide whether this is a Pythagorean triple or not. Now it's the same thing as tell me whether this is going to make a right triangle or not. Same thing. So we look at number 2, and they're saying these are the 3 sides of the triangle. Now you don't have to draw the triangle, but I'm going to do this for you. Look at this and tell me which one's the longest side on number 2. Try the square root of 7. The best way to do is do it in your calculator. We're looking at these numbers. I should have put them up. Number 2, we're looking at 1, square root of 7, and 5. And all you need to do with that square root of 7 is to see if it's the bigger side or not. You need to do square root. Okay. The square root is above the square button. You see it in green right there? You can use this button, but you have to push the green button to get that. So we're going to go green and then this button. That gives you the square root. And then you say 7. Oh, and if it gives you that, just toggle. This gives you the decimal. So it's just 2.6, right? So the longest side is actually 5. Is that correct? So that's C. The others can be A and B, and let's plug those into the Pythagorean theorem. So I have 1 squared plus the square root of 7 squared equals 5 squared. Now I'm going to test this out to see if it's actually a true statement. This is the last page. Are you with me, Christina? Okay. So 1 squared, of course, is 1 plus, and this is what I thought you might have a problem with. But do you see a squared on a square root? So I have 7 equals 5 squared is 25. So I have 8 equals 25. Is this a Pythagorean triple? No, because it does not create an equal or an equivalent equation. If it doesn't fit the Pythagorean theorem and come out with equal sides.
Why, you just came and you showed me how to do the square root 7, but why did you not put 2.6?
Because the only reason I had you find the square root of 7 is some people don't know, is this one bigger or this one? And so when you were looking for your bigger side, you kind of need to know sort of what that's equal to. Then you know this is the biggest side. But you are still going to use the radical. It's actually easier because a radical and the squared cancel each other out, and you have just the 7 that's left underneath. So do you understand Pythagorean triples? We're going to be using this theorem. Isn't that kind of cool? It's an easy theorem. It's the only one. You get to practice over and over and over again. Any questions remotely?
I don't know how to find the square root using this calculator.
Say it one more time. I got close.
Oh yeah, I don't know how to find the square root using this calculator, please.
On your calculator? Okay.
Yes.
All right. Now it's backwards to me, so I'll find my fingers.
Okay.
Okay, on the calculator, you have an x squared, and you know that the square root's the opposite. Notice that right here above the x squared is the square root sign, right?
Yes.
Well, they have designed this calculator so each button will do two things. It will do what's on top of the button by just pushing that button, but it will do what's above the button if you push the green button or second button, push the green button first. So in this case, I need the green picture. So I'm going to press green and then the x squared button. And you notice that it gives me the square root now. And then the square root of 7. Now, when I helped Christina and we pressed enter, it said square root of 7. Well, that's no help at all. But you have this magic toggle button that I love. It's right here. And it will change fractions to decimals. It will change square root radicals to decimals. Okay, so the square root of 7 is approximately equal to 2.6, and that's how you know it's not the biggest side. Did you
Okay.
catch that?
Yes.
Okay, there's lots of magic in this little blue box.
Thank you.
So anything you need, I will try to help you with it.
All
Is
right.
that your
Thank
only
you.
question?
Yes, ma'am. Thank you.
All right. Well, then as far as the lesson, I think you guys are ready to go. Pythagorean Theorem. You'll find it in an awful lot of problems that we're going to be doing now.